going to present over the next sort of half an hour or so, it isn't generally necessarily to demonstrate any new technologies. It's going to be based on the tilting wagons and the modular process. And then I'll move forward through some of our most recent achievements, if you like. But what I want to talk to you about today is certainly modern S&C track renewals, or I perceive it to be. Some of the things that I'll talk about is the early deployment and the modular journey alongside the business improvement team, and how we've adapted over the year since 2006 to kind of adapt to accommodate the 7-day railway aspirations, short possession times and things like that, and how we've become more efficient. I'll also touch on something that's become very important over the last 18 months to 2 years or so, which is the collaborative approach and the management approach to that, and some new techniques. Like it says there, as I go through the presentation, I'll discuss some new processes that we've adopted and some technologies along the way. And then towards the end of my presentation, I'll talk about the achievement of the 80 mile an hour and back at Wigan Springs branch, which was one of the work sites during the 9-day blockade. I've kind of chosen this presentation in recognition that there's many people that benefit and contribute to the final output of our track renewals world, including the many designers and everybody. I think it's important to stress that although we're achieving all these things like 80 mile an hour and back and things like that, it starts probably in a design office. So that should be kind of commended, really. So I'm here today basically to promote the renewal side of it. There may be some of the technologies in here that people have witnessed or that use different to us. Not necessarily saying that ours are the best, but they're certainly what we've perceived to be the best and what benefit us in the challenging sort of like access and possession opportunities that we get these days. And I think it's just best to be able to share best practices. So if anything I can give today that you may be able to take away to use just to benefit the overall network strategy for S&C renewals, that's I'd be happy if you could take some of them away. I won't be talking about other disciplines in too much, such as S&T and OLE and E&P, unfortunately. They obviously have a big impact on successful track renewals, but I'll just specifically keep it P-way as best as I can. I also don't intend to talk on the financial side of things either. I wanted to keep things practical rather than theoretical, so you'll notice that there's lots and lots of video footage in there. I do assure you that it isn't a way of just not having to say much. It's you know, because like I said, you know, I feel that my presence here is to show people actually what goes out on site. So I've got lots of video footage and photographs that hopefully people can benefit from that don't get the opportunity to see a site in action so much. Presentation, it does supposed to last about 45 minutes. It may go on to a little bit of an hour. We'll just see how it goes. So let's crack on. So early deployment, I think it's important to talk about this. Like I said, although it began in 2006, it certainly benefited us how we've progressed and got better at what we do over the years. And not necessarily just because we're following the modular system, but it's actually just as far as production rates and quality of installation goes, it taught us a lot of good and great things. So we took some of the lessons learned from the business improvement team and the modular journey, and you know, adopted them for successful track renewals. So to align with customer requirements of the 7-day railway aspirations, the business improvement team, who was kind of managed by kind of Roy Hickman, Tim Fenimore that spoke this morning, Kevin Percival, Nick Matthews, who I've seen here today, just to name a few. Like I said, to align with customer requirements of the 7-day railway, they collectively had a vision which became a real mission, and they were challenged in making S&C track renewals as streamlined as possible, obviously whilst paying great attention to every employee's safety on site. So I'd just like to talk to you a little bit about the early deployment journey, just to paint a picture of how we've progressed over the years. This is a targets table that was actually taken from the business improvements team's original presentations, which I think Tim again put together for us, and it basically provided the instructions really of what we were supposed to achieve from sort of 2006 through to sort of like 2011. Just to give you a quick overview of what the table represents, it's split into 3 sections. The first section being the early deployment, the second being Mark 1 modular, and the third being modular and tilting wagons, which I'll explain in a little bit more detail in a moment. If we just look at the top there, the level 1 on the red on the left-hand side, what this was basically about was installing the turnout there, as you can see on the left. In 2006, we were commonly installing a turnout in 37 hours, and again to suit the 7-day railway aspirations and benefit from the modular tilting wagons all the way across to the right-hand side on the green, on the same level of the turnout. We were looking to deliver world-class track renewals in 8 hours, 8-hour possessions, which is basically an 80% reduction in time. So that was the challenge, and everything in the middle were the steps towards achieving them. So if you look at, in a little bit more detail, an early deployment, the first sort of phase. Early deployment, the dates for achieving some of these targets was 2006 to 2008. And it was generally surrounding behavioural changes only. There were no real new tools or plant, no new processes or technologies. It was all about getting smarter and challenging production rates. So like I said, like it says, it was behavioural changes. Progress Rail were kind enough to allow us and Network Rail to use their facilities at Beeston, where we could go down and basically a big train set was there and we could play with production rates, machines, trains, you name it, and we could benefit from that, and we got good, thanks to Roy and the team and Tim for allowing us to use Progress. We got good. Just looking at the picture in the background there, just to kind of emphasise the behavioural changes and some of the things that we've adopted just to sort of like become more proficient and efficient. If you just look at the picture there, that's of Bolshaw Lane, again on the Wigan, on the West Coast Main Line blockade. If you look at the site, once upon a time that had probably been strewn with materials and plates and tools, what have you. Nice new ballast level there, no tools or anything about, but most importantly, no manpower. We've streamlined down on manpower, and that's obviously a big safety, no positive note, there's nobody there. There's a Kirov crane just about to install a panel just over end there, and if you just look on the picture, just another example of being efficient, just something simple as this. The blue circles are just highlighting how we've positioned plates and facetters ready to receive the next panels. So it's stuff like this that we were able to learn and adopt just to make things a lot more sort of like quicker. One of the first sites where we'll be able to adopt the behavioural changes and put some of the things into practice was back in 2007 at a site, Newton the Willows. Newton the Willows was a double junction, a crossover and a turnout, which historically would have taken 167 hours to install, and we managed to do it in 75 hours. We were experimenting a few things. You've all seen there the twin dozers, just to try and get things as fast and higher quality as possible. That was a whopping 45% reduction in time. Everly was commissioned, and so was the points and the points. And we, most importantly, were ahead of that targets table of the 20% target improvement by the end of 2008. So, let's move on to the next section of the targets table, which was the second section, which was Mark 1 modular. The target dates to sort of like succeed in the Mark 1 modular process were January to December 2008. This was the introduction of the modular split bearer system, which we've talked about quite extensively this morning. And you can see in the background there the shrouds that have gone over the top of where the bearers have been spliced. Most of these layouts at the time were delivered by road, out of gauge. We were still waiting for the tilting wagons, so we had to use other methodologies to deliver the panels to site, and the obvious one was road. So most of our sites were delivered by road at that time. And they were installed on site by means of Kirov cranes or sometimes even pens and lems. At this kind of time as well, to suit the bearer tie, we needed to ensure that the ballast formations, the ballast levels, should I say, between splits needed to be really accurate, to enable us to put them shrouds on and for the S&C to actually tie together properly. So that was where we kind of introduced Trimble and 3D surveying equipment, and including .pro ballast files and things for dozers. So dozers were automatically following surveying equipment for better ballast qualities. Going back to a couple of our first sites where we were able to sort of introduce and get used to Mark 1 modular was at Moss Band up near Gretna, and obviously we did a site at Crewe Coal Yard. The following slides just show our first sites, like I said, and this was generally an interim stage before the delivery of the tilting wagons. So most of the emphasis for me personally, you know, although we were still facing challenging times with reduced access and what have you, this process really for me and for us within the LNW was to get used to the split bearer system and how to install it and how to work with it and manipulate it. Well, wrong word, but you know, install it. Some of the lessons that we learned on the site are there up on the screen. You know, some are positive, some are negative. Some there are the additional haulage that was required for moving panels around site. You can see there we were overlifting over distances, which added time. But one of the benefits was the 3D dig control, which I've mentioned, that gives us better formation. Outer gauge loading required extra wagons and added risk to the programme. Tandem lifting, we had individual lifting beams, which was harder to control before the introduction of the modular beam. But again, a benefit, the 3D ballast control gave us the great ballast levels. We introduced the guide plates for quicker installation, panels, and obviously the ballast, nothing new really, other than the technology behind the remote triple whacker systems giving us great ballast compaction. So they're just a couple of pictures of Crew Courtyard and Moss Band. So magnetic lifter, something that was devised to lift the shrouds, because they were over 25 kilograms, don't recall what they weighed, but what was that, sorry? 41 kilograms, so two-man lift with a magnetic lifter, and you can see there the coach screw, which was designed to install the coach screws down on the bearer splice, 8 screws. So, final sort of like stage of modular was the Mark II modular. Target date to achieve some of these was October 2009 to April 2010. Again, modular split bearer, and it was the introduction of the tilting wagons themselves. It was where things kind of got a bit more exciting and competitive, if you like. You know, there were challenges, and there was it was definitely a great honour for Babcock to be able to be one of the first contractors to install this. So we were looking forward to that. They were installed on site generally by Tandem 250 system with the modular beam. Like I said, the introduction to the modular beam came then, and it's where all previous training was obviously put together to create the most efficient work site. Okay, for those that don't really know a great deal about the tilting wagons, I know they've been around for some time now. Some people may have had the opportunity to see them, some people may not. I've got another video here that just demonstrates what the tilting wagons look like and how they operate. So they're just in the tilting mode that's engaged to get to site at the moment. Just get a few captions on there, just highlight what's the modular beam. Then the cross beams attached to the modular beam. The cross beams actually lock into the panel, and then the modular beam comes and then locks onto the cross beams then. And then the cross beams actually lock to the tilting wagon itself then. Locks the panel to the tilting wagon. And this is actually the tilting wagon in action. Tilting to the transit forward, says there. It is being lifted there. Boys out as well. And let's see there, it's now engaged and safe to travel to site with the panel on the tilting wagon. tilting wagons before? There you go, that's how they operate. Moving on. As Roy mentioned at the beginning, as he introduced me, one of the first sites, or the first site in the UK to receive the modular system by tilting wagons was at Banfalong in 2009, October 2009. Obviously I've mentioned already that Babcock wanted to be the first contractor to install that, and I was over the moon to be one of the engineers to sort of like contribute to the planning and the delivery of that site. The footage again shows some of the lessons learned as we work through. Just the sheer size of the tilting wagons there show you with the four resolutes on the right there. They're arriving on site at Banfalong. Mind the wire height was all about not so much the panel itself, but the beam wagon was designed with a barrier around it. One of the things that the modular beam introduced was the non-requirement to work at height, but hooking the beam on was one of the only things that we had to do at height, so we put the barrier around for the protection of the staff. Just needed to make sure we got adequate wire height to lift the beam over the wagons. Another thing that we had to sort of pay attention to was considering the wagon slew. As the wagons go flat, they slew out to the left or the right, whichever way you want. We need room to run the gear off cranes or whatever up and down one side, and then we should just take nicely to the fact that there's nothing in the sets or what have you to foul, or even if we work in ALO. As I said before, this was the introduction to the Trimble equipment and where we started village, and then just using 3D surveying equipment. Just a picture there of the rail front that we're trying to set outside. So yeah, no flame cutting. Just stress the fact that every first cut that we do is always flame cut, just so any stress in the rails disperse in a controlled fashion, rather than if you cut through with the disc cutter, it just snaps open. We do use both from the initial flame cut. Just showing you there that the chosen sort of scrapping out methods was using one of the Kieran 250s, which we use over end, and obviously just 3D formation there, just showing the dozer pushing through, controlled by the 3D, giving us quite a decent sort of formation level. And we've got the same 3D controlled bottom ballast. One of the benefits for me for this, one of the things that we always used to do when we used 2D lasers, used to have to do what was called a blade and a half pass, because the blade itself isn't as wide as what the pig is, so you have to come back and do a half blade pass. When you did that half blade pass, it always used to leave a irritating little ridge down the middle that you just couldn't quite get rid of. So the 3D Trimble's got rid of that, which is obviously a great benefit for the modular installation. And that's literally the first panel coming off tilting wagons there, being loaded at Babcock. So that's the first switch panel on the ground from tilting wagons. This is going to keep going on, isn't it? Thank you for that kind of comment there, just showing the string, but you can't get away from that. Just fine lining the switch toes there, and again the guys bar code screw just tightening down the shrouds, and there is a pattern to that, the crisscross method. Unloaded auto ballasters is not something that's uncommon these days. That's the preferred method. We don't like to use steam carriers these days. Like the electrorated wagons, we like to use the auto hoppers there to drop the top stone. And then we just we finish off with tapping it, and that just shows you there what kind of impact it has on the rail. Banfalong did receive some press. You know, it was a very high-profile site, being the UK's first tilting wagon. So we did get some press release that I thought maybe to show. Wigan says it was 21st century track relaying. We had got onto Network Rail's website. Wigan wagon rolls out renewals in record time. Say that after a fight or two. Rail infrastructure, first modular switching crossing installation was undertaken, and then one that I'm proud of because I took that photograph, rail engineer, tilting wagon delivers milestone. So that kind of shows the excitement and importance of that. So I'm conscious I've talked about that quite a lot, so just to summarise up the modular journey, early deployment was behavioural changes for efficiencies. Mark 1 modular was the introduction to the split bearer layout, which was delivered by road. Mark 2 modular was split bearer layout delivered by tilting wagons and modular beam. The overall concept was to achieve an 80% reduction in time to suit the 7-day railway aspirations. And just to note, today we're achieving a consecutive kind of 50% reduction in time. A lot of that's down to the fact that a lot of the works that we're doing at the moment are remodels, complicated remodels with multidisciplinary disciplines in there. Sorry. And then, just to let you know, 80% has been achieved over some of the sites in the past. Probably not as many as we'd like, but certainly at Whitlock's End, Farrington, a couple of other sites. And we do endeavour to continue to work towards the 80% reduction in time by using the technology in the modular tilting wagons. As soon as we can kind of get them sites where we can adopt that technology, we will continue to do so. So, one of the things, obviously, the tilting wagons themselves have contributed vastly to the benefit of quicker installation, but it shouldn't be forgotten that there's a lot of people as well that are required, to do this, to buy in and to actually employ this. 2012 saw an opportunity to consider accelerating 14-15 work bank into 2013-2014 to complete some of the complex junctions before the onset of CP5 in April this year. So this kind of leads me on to the collaborative kind of approach, really. What was a steady 25 point ends a year turned into 96, a very challenging 96. So to do this required a collaborative team of individuals to adopt this going forward. Our programme manager, Mr. Paul Marshall, brought together a fully united team of professionals, professional organisations, and we formed a collaboration. You can see some of the partners up there that we were lucky enough to work with. So all these partners collaborated, and then all the individual branding disappeared, and we created the Strength Through Collaboration brand there, which completed the unity. So this obviously changed, that's the team there, some of the team. This obviously changed the culture to how we kind of worked. It created a more professional environment, should I say. There were clear and defined organisational structures, clear defined roles and responsibilities, mutual respect for one another, which was good. People were valued in making a difference, and also people could take pride in success. People felt good about being involved in this collaborative organisation. They could see the goals, and everyone had pride in achieving them goals and felt part of something special. So, one of the first sites where we had to put some of this collaborative work into the test, and also where some of the perhaps where we couldn't employ some of the 8-hour and 16-hour track renewals, was at Stalybridge, where we had to adopt more of a blockade approach. So this was for the remodel of life expired junctions. There were major works to OLE and S&T as well as P-Way. And this was for better journey times, passenger comfort, and for better maintainability. So Stalybridge here, just got some footage, some time-lapse footage of how we continued and carried out the works at Stalybridge. Which I knew was going to stop. these 8 towing wagons, that's what that's said, but obviously a lot of them were pre-delivered to site prior. We use 250 crane generally for installation, tank installation. And then all in all, there's over 100 panels to be installed. There, we will open scrap about 70 metres an hour. Next week, 350mm links, 75 metres per So staying with bridge remodelling was obviously very challenging. It definitely prepared us for some of the challenges ahead, and the upcoming projects such as the West Coast Mainline 9-day blockade in summer last year. That's just another example of how we collaborated with the operators who distributed chocolate bars on the platforms, just to inform the public of the disruption. So again, just another example of how we work together to achieve what we set out to do. I mentioned earlier about other factors that contribute to a successful renewal programme. I'd like to just touch on a couple of management techniques that helped us during the planning and implementation stages of the 9-day blockade, and obviously which we're still working forward with. So this management approach is visual management. That's the visual management master board. This was adopted after seeing how organisations such as Rolls-Royce and Bentley used to monitor their project life cycle and the progress of it. So these photos show the visual management boards listed across the top of the key milestones and requirements, and it adopted the red, amber and green approach. The milestones across the top were obviously owned by different disciplines, and then within the milestones there was subtasks that they had to do. Each subtask had to be completed before the green is presented onto the board. For those that don't make it green or highlighted red, we then have a risk and escalations board. The risk and escalations then go onto the board and are closed out and discussed in forums until they're closed out. This process identifies risks and actions early, it promotes teamwork, definitely provides an understanding between disciplines. It shares problems early and makes people understand each other's problems in the hope to assist each other in sorting them out. And most importantly, it's quick reference. So if anybody comes in to look at what sort of status the project is in, you can literally just get a quick snapshot of the board and it tells you where the concerns are, if you like. So another thing that we had to consider was whiteboard meetings. Historically, we've obviously used whiteboard meetings to promote and show people the work content and methodology. For the West Coast mainline blockade, it was actually going to be quite some task to be able to explain a 16-mile possession with 4 work sites, with engineering train movements, plant and crane movements, freight windows, and the giving up and retaking of work sites, if you like. We wanted to provide key staff with a clear overview to the work content and to the geographical layout of each site in a quick and concise manner. It's not true BIM, but with BIM in mind and having a bit of a positive attitude towards it, we wanted to try and introduce some virtual showings of things on site. So basically we approached Salford University to help, to ask for some help into how to demonstrate the overall sort of like work requirement, if you like, of the West Coast mainline blockade. After quite a lot of work, this is what we came up with. I might just skip through this.
On the 13th of July 2013, the LNW S&C collaboration based in Crewe have been given the opportunity to carry out multidisciplinary engineering works on the West Coast Main Line during a 9-day blockade between Winwick and Exton junctions. Using virtual footage, the following video provides an overview of the proposed new layouts at the 4 main junctions involved: Goulburn, Bamfalong, Wigan Springs Branch and Bolshaw Lane. This should help you identify real track layouts, proposed access points and welfare facilities so that you are familiar with the site upon your first visit. Goulburn. Approaching from the south with the down fast on the left of the screen and the up fast on the right. P-way works involve the replacement of 5 life expired point ends and associated plain line, including 3,758 tonnes of new ballast, 2,401 new concrete sleepers, 3,011 tonnes of top ballast and 3,022 metres of rail. Overhead line sees the installation of 3 new stanchions, 100 metres of contact wire and 100 metres of catenary wire. As we approach site, the turnout to the bottom right is to be replaced, the crossover and the turnout onto the 4-line section on the left. Electrification and plant will be installing 1 D&O power upgrade for new points equipment and 5 new sets of point heating. Site access and welfare facilities are located on...
I think I'll stop it there anyway. That's basically the end of the first site at Goulburn. It goes on to show the other 3 sites of the West Coast Main Line. But you get the general concept. It gives people a quick and concise overview of the actual geographic location of the site, where the welfare facilities and access is located, and also the work content. Quite a simple concept, but did provide the overview that we ultimately wanted. I'll touch a little bit more on that later in a moment, but we then went on to speak to Salford to work on how to better demonstrate methodologies. But historically, methodologies were presented in this kind of format. So in the whiteboards, just to sort of like present how we actually carried out the track renewals and what process it followed, we just show simple Microsoft PowerPoint presentations that just show where trains, where machines and that's supposed to come from, and then it basically just follows the linear process of how we start scrapping materials out to trains, how we start digging, and then, like I said, it works through in a linear sort of fashion. Very simple, but that's really the idea, and it helps people understand exactly where trains and how plant and things operate and move on site. And that simulates machines magically moving across the rails. And also the installation, yellow highlighting tilting wagons, installing the S&C there. So quite a powerful tool really, simple but quite powerful in the ability to demonstrate exactly how we're carrying out the track renewals works. Another tool that we use, and we've used for some years now, is the bar charts. These bar charts will literally go down to 3 minutes, for every activity, including disc cutting, flame cutting, and then all the sort of like methodologies and how we're scrapping things out and how long they take. So them two combined actually create quite a powerful tool to demonstrate how we're carrying out the works. One thing, just going back to what I was mentioning about Salford University, we wanted to combine the PowerPoint and bar chart to produce like a 4D virtual model to interact with, to learn and to monitor progress. So after lots of kind of hard work, alongside Salford University, we've been able to produce this following kind of footage that we used. Which again, this was with BIM in mind, just to introduce the virtual aspect of track renewals, to give people that overview. So this is Wigan Springs branch. We just stick with Wigan Springs branch now for the West Coast Blockade. It's going to be the focus really in the remainder of the presentation. The people may be wondering what the 4D, the fourth dimension, is to 3D. The fourth dimension was the addition of time. On the right hand side there you can see the activities that are being undertaken on site. So there we're loading scrap rail, sleepers and S&C to train 6 Alpha and 02. That information was taken from the bar chart, incorporated into the staging videos, and everything's kind of running in real time. So one of the kind of benefits from this is obviously it paints a picture for people also along with the time. So people were able to take this video away and learn the blockade in their own time if they liked. But definitely sort of painted a picture again of how the 4 sites combined were going to be implemented. Going forward, we want to adapt on this and continue to use this method of demonstrating methodologies working. What I'd like to see is in operations rooms, such as those at West Coast Mainline, is to be able to run this video footage in real time, so that people inside can see exactly what's supposed to be happening on site at what specific time. I'd also like to be able to adapt it in a way that, should there be any program slippage on site, there may be some form of input mechanism to the software to be able to calculate a new sort of methodology or strategy going forward and see what impact that has on the site, whether it would overrun or whether it be completed successfully. I'll continue to work with Salford University to adapt and introduce that technology as soon as I can. So you've seen how we've used some of the management techniques and new technologies to plan the blockade works. I'm going to stay with Wigan Springs branch for the time being till the end of my presentation and just discuss about the 80-mile-an-hour handback that we achieved in July last year. So if we just move on through the presentation, that gives the existing speed diagram at Wigan Springs branch. It shows you basically a double junction there with 50-mile-an-hour turnouts, 110 mile an hour on the main lines, 50, 60 mile an hour respectively on the downslope and the upslope. That's the proposed track layout. You'll notice that there's no real requirement for speed increases. We've kept it's just basically opened out into a series of turnouts and a crossover for passenger comfort and better maintainability. So, moving forward, we had to plan how we were going to adopt the 80-mile-an-hour requirement. We were challenged to open 80 mile an hour TSR following SSC renewals at Wigan Springs branch. We asked why it was Wigan Springs branch, and the reasons being that there was no pole formation history, it was on a straight track geometry, and it was on one gradient. It was also at the front end of the programme where adequate time was available for multidisciplinary works, and also it gave us a bit more time to dedicate to track quality. So the strategy was to engage industry experts and key suppliers, including Babcock Network Rail, Core, AP Webs and A-Plant, amongst other people, but these were more the people that could actually have an impact on site. We established work groups and discussion groups early in advance so everybody knew exactly what the mission was and how we were set about to achieve them objectives. I mentioned before that we use latest engineering technology, including 3D and Trimble. An important one at the bottom was just using standardised track renewals techniques and production rates. Again, we weren't using anything out of the ordinary. It was just something that we adopted from the early deployment and modular days that we stuck with where we get best efficiency. Can't forget the teamwork. We had a dedicated team of engineers and site managers, dedicated plant operators, and track gangs and dedicated care-of operators as well. They engaged in regular team meetings and briefings to understand their responsibilities and requirements. So everybody kind of bought in early, like I've said, and understood the process through to the end. When we look at the project delivery, as far as excavating and bottom ballast goes, we use Trimble 3D SCS 900 dozing to achieve design levels and automated dozing. The design has also included ballast ramps within the dozer files, something that's caused us some problems over the past where we're spinning dozers and trying to sort out ballast ramps. They're actually included in the dozer file, so the dozer can actually follow and put the ballast ramps in itself. We engaged AP web operators for best production rates. So in essence, we just kind of got the best people for the job on site to get the buy-in and the best production rates. We used the triple whackers for even compaction. We even whacked the ramps. Just a comment there that I've missed. We also adopted 2 D lasers as a backup. Everything was set out at 5 metre offsets as opposed to the normal 10 metres on a straight that we adopt, and that gave us better track alignment and levels. And we also introduced the falling weight deflectometer to prove uniformity. I'll touch on that in a moment, but the falling weight deflectometer just measures the stiffness of the ballast. We also adopted and used the geotextile and geogrid for additional track bed stiffness where required. And an important note there that Corec, who provided all the Trimble gear, were on site 24/7 with technical support, because we understood the importance of having to install the track with the 3D equipment. So just a quick demonstration of what the falling weight deflectometer is. Right. This is the best one. Slow motion. I actually did a PWA technical seminar up in Glasgow a couple of weeks ago, and it did raise quite a lot of interest, the falling weight deflectometer and how we used it. I'll go through it in a little bit more detail in a minute. You don't want to see it again, do you? Do we? Just catch up. So, this was an extract from construction proposals for 80 mile an hour handbag that was put together by Colin McAteer, one of our engineers, and it basically says, for the purpose of measuring the track bed stiffness, the Zorn ZFG 2000 lightweight deflectometer is to be used in accordance with the manufacturer's instructions. Dynamic stiffness values are measured in meganewtons per metre squared and are to be recorded at trim subgrade formation level following compaction of subgrade with a triple whacker plate weighing between 1400 and 1800 kilograms. Stiffness values are to be recorded every 10 metres along the centre line of the track at trimmed formation level, then the corresponding position above the formation on compacted bottom ballast level once installed. Some of the parameters there, we've not really historically got a lot of data to support this technology. We managed to get some data from off the continent there, which basically gives the recorded dynamic modules there. Just looking at the less than 15 meganewtons per metre squared, it gives you the proposed action. So for that instance, if you're looking at the bottom there, it was to dig down to 0.75 metres below the bottom ballast level and install 50 mil of sand, geogrid and 700 mil of bottom extra ballast and geogrid. There's different sort of like proposed actions as we get better track stiffnesses, but generally from on the right hand side there, we've got estimated compacted ballast stiffness values from previous studies of the West Coast main line, and they were generally coming out obviously between 50 and 80 meganewtons per metre squared. So they were just guidelines really. So again, it was more the word the uniformity. We were using the weight deflectometer to measure through the site to make sure that each spot that we were measuring was giving us the same values. And collecting data, it was about collating data this time round rather than using fixed data to prove actual ballast stiffness. So, S&C installation onto the new ballast bed. We just adopted the normal tilt and wagon delivery. We used the Kirov 250 tandem installation, and all the track poles are pre-built at the suppliers and delivered direct from the manufacturers for better quality. All the installation was Trimble guided again. Horizontal alignment was installed to plus or minus 10 millimetres. It was probably better than that, but they were the parameters. And again, it mentions there that 5 metre offsets and relatives were used for additional track quality checks. Just an extract there from the standards. Generally between 50 miles an hour and 80 miles an hour, we were looking at a 5mm tolerance, a better tolerance for achieving the 80 miles per hour. Top ballast was distributed in the same way as normal from auto ballasters. Construction tampers by two S&C tampers that were connected to tandem tamp through the S&C long bearer section, connected through the umbilical cord. And the front offset files were created again on the ALCs, an automated device on the computer that you can input on the tamper. Again, usually, specifically on a straight, we put them in at 10 metre intervals, but on this occasion we put them at 5 metre intervals, which gave us better track quality outputs. We also adopted the maximum lift of 20mm where required. So then just move on to the 80 mile, actually achieving the 80 mile an hour handback. Just to mention there, one of the things that did benefit the 80 mile an hour handback, the 9-day blockade on the first Monday, Tuesday and Wednesday evenings had freight traffic going over where we had to suspend the work site to pass key trains. So that obviously benefited and contributed to better ballast compaction. We also were able to fully weld all the site. The speed raiser was identified early, so we had the complete buy-in support from the collaboration. The speed raiser also closely monitored site progress from formation through to bottom ballast and installation. And like it says, he was fully supported. Track quality information was provided to the speed raiser, such as including your early heights and staggers. We're using the GEDO trolley to provide information such as twist and gauge and everything like that to give the speed raiser more confidence that track quality was high. And more importantly, we gave adequate time to the speed raiser to carry out its checks. Once we had the successful handback at 80 mile an hour, we obviously didn't leave it there. We had some contingencies in place. Sorry, I'm just one step forward. We had some contingencies in place, 50 mile per hour ESR. We also had these backhole drilling plan in place should we not be able to weld everything. Training was given on rail drilling. The drilling teams were identified as critical resource and were available 24/7. Robel clamps and 6-hole fish plates were on site, and again adjustment switches were on standby should we install at sort of like low temperatures. And then post-work monitoring and maintenance strategy. We had multidisciplinary teams on site 24/7 for 1 week to undertake track monitoring. Vertical and horizontal alignments were checked daily. Void meters were installed, as it says there. Daily walkthroughs with the maintainer. Twist checks. S&C were on site for rapid response should there be any sort of points failures. And ops support was fully available for any line blockage requirements should any of the track quality deteriorate. We also had tampers on site at Wigan Springs branch which were there ready to be deployed again should the track quality start to deteriorate for the 80 mile per hour handback. Then just some site photographs just to show you the quality of the ballast. Just the dozer there finishing off the bottom ballast, the whackers. They're the triple whackers compacting the ballast. Again, just some photographs showing you the high quality installation of the ballast. Nice ramps there. The track on the right hasn't been tamped yet, and that's been installed. And that's half your modular S&C. And again, just showing off the S&C there, the original alignment put in, and that's just how the ramp looked. Offloading ballast from auto hoppers. And that's the final product at Wigan Springs branch. It was open to 80 mile an hour. Which we're very proud of. So, that race from today. So post-track quality recordings. If we concentrate across the top band on the first eighth, we're looking at the wavelength 35, AL35 wavelength. We've basically got a 0.62 standard deviation, which in simple terms is the ballast kind of stiffness, if you like, and the track quality. We've got 0.62 of an SD 4 hours after the blockade. About 3 weeks after on a follow-up tamp, we've got, moving across to 35 again, we've got 0.66. About another 3 weeks later, we've got 0.63 SD, and then moving across again, we've got 0.58, which is obviously getting better. What that highlights, you've got a lot of green on there, and also the ballast stiffness and track quality was holding up, so we did something right as far as the track quality goes and the installation of the bottom ballast. So that pretty much brings me to the end of my presentation. I've got one last video to show you, which again is Babcock's promotional video of the West Coast blockade and the successes of it.
I think it's just the phrase, the best blockade ever.
We'll do that.
Well done, guys.
Bibby. I'm S&C Development Manager. This blockade approach has reduced the full cost renewal by up to 20% and saved Network Rail almost £3 million.
My name's Ian Hughes, Senior Engineer for S&C Track Renewals. Over the course of this blockade, we have used 6,600 sleepers and 21,500 tonnes of ballast.
Hi, my name is Dad Waters. I'm one of the S&C supervisors for the S&C Renewals. Over the course of this blockade, 9 days, we've used 61 engineering trains, nearly 900 wagons and 4 tampers, and it's been harder than hell.
My name is Andres Alvarado. I'm an engineer. I work for ISS Labour, and over the past 9 days of the blockade, we've been using the latest in GPS technology to improve track quality.
I'm Nav Seeker, I'm the Project Management Assistant for LNW North Track Renewals. We have facilitated industry needs with 3 single line working opportunities through the work to pass key trains.
This blockade has improved the reliability of the network by installing new signalling equipment and high-drive point operating equipment, and we've also removed free and reliable switch diamonds from the network.
Hi, I'm Rob Munro, Project Manager for Development of the S&C Collaboration and Crew. The work here of this blockade are going to improve reliability, increase line speed, and overall give a better customer experience on the West Coast Main Line. We've done this over 2 years in advance thanks to this blockade, and we've done it by working with our collaborative partners, ensuring that our work is to time, to cost, to quality, and most importantly, to safety.
I have a very warm and positive view, and what I'd like to be able to do is document the digital blockade and actually roll it out going into CP5, because that's the way to run a blockade.
The thing that stands out for me is the teamwork that occurred in the planning. The thing that stands out for me is the teamwork that occurred in the planning of the work and during the work. The work's were meticulously planned, that you do sometimes get unknown events, and these guys really help.
All the work that's done, the blockade is coming back early, our commitments to our customers are met. Absolutely fantastic, first class job.
And that is pretty much me. Thanks very much for listening.